So this is the first of 3 short videos on blockchain technologies. They're short and high level, so if you want to find out more information, check out some of the links at the end of the video. Essentially, a blockchain is a distributed ledger or database or record of the transactions that have been validated across a peer-to-peer network. And Bitcoin is the most famous application of that tech. In Bitcoin, the ledger is basically the list of Bitcoin transactions validated across the network. And generally speaking, blockchains share some common features. It's a mean to store and secure blocks of data using cryptography. The transactions or messages that have been validated across the network get aggregated and stored into units of data called blocks, which then link to previous blocks, forming a chain of record, hence the phrase blockchain, that goes all the way back to the start of when the blockchain network was created with the issuing of the Genesis block. And those blocks of data that form the database then replicated on lots of different nodes or computers, so everyone who's running a node has access to the ledger. And there's no central authority in charge of a blockchain network, so participants who are transferring assets, digital assets, or sending messages across the network aren't relying on a third party to verify that transaction. Instead, they're relying on the software, in particular the consensus algorithm, to verify and validate that transaction. They're also trusting that once that transaction is validated and recorded on the blockchain, it can't be changed, it's immutable. Let's look at Bitcoin as an example. Let's kick off with some explanation of some terminology. A wallet is often a software client which basically stores your public and your private key. Those keys are basically a long string of numbers generated as a pair that are mathematically related. Your public key is used to derive your Bitcoin address and your identification, your identity really on the and location on the blockchain network. And is publicly available, and your private key is private to you. You have an account which is basically a pair of those keys, and it's controlled and operated by your private key, and that's why your private key is so important. Bitcoin, the cryptocurrency which is traded across the blockchain network, or the Bitcoin blockchain network, isn't stored in a wallet. It's decentrally stored on the blockchain and tied to an account. And that's why your private key is so important, because your private key is basically your means of authority over that Bitcoin which has been sent to that particular account. So if you lose your private key, you're in trouble. And finally, a node is a running implementation of the blockchain software which can then connect with other nodes to form the blockchain network. So if X wants to send some Bitcoin to Y, what happens? X will log into his software wallet and access an account. You can have one account in the wallet, or you can have many accounts in the wallet. Once that account's accessed, he'll create a transaction. Essentially, it'll say, amongst other things, this is my Bitcoin address, X's, identifying where the Bitcoin is coming from, and this is Y's Bitcoin address, so it identifies where the Bitcoin is going to, and this is the amount of Bitcoin I want to send, and then X will sign that off using his private key, so it's verified, and then the transaction or the message will be broadcast through a node to the network. And that can happen because the wallet might form part of a node, or it might interface with a node that X is using. And then nearby nodes, mining nodes, essentially nodes that have downloaded the mining software, will compete to verify the transaction. They do that by solving a complex mathematical problem related to the transaction. That's the consensus algorithm, and for Bitcoin it's called proof of work. You prove you've completed the work when you've solved that number or that mathematical problem, the hash function identified against the transaction, the digital fingerprint, and then you record that in a block of data. So the message gets added with the hash function into a block of data and gets recorded on the blockchain network, so that we now know X has transferred his Bitcoin to Y, and it's located at this particular Bitcoin address.